Hi, it's Mrs. Guest, and I'm creating this video to give some help to those of you who may be coming this week to work on corrections before I formally grade the test, or who may work on corrections for partial credit after the formal grading. So just a couple things I want to highlight now that I've had an opportunity to peek through everyone's tests. Starting with the front page, please make sure when you're defining your variables that you are very clear about what each variable represents. Most of you will probably use X and Y as your variables. You're not required, you could be more creative, but just be crystal clear as to what that variable is. Okay? You'll then write your two linear equations, one for Geno's and then one for Venetian, the two different pizza places here. The graphing part is maybe the trickiest part of this exercise. They don't give you a scale. You need to decide on one. Okay? So given that, you need to think carefully about the potential range of values. If you have difficulty with that, you can grab some graph paper and do a little experimenting or modeling and just attach it to your test. Remember, you do not have to start at 0. You can start further along in the scale. If you were to do something like that, you can use the little lightning bolt to show us you're starting someplace else, someplace other than 1. If, for example, you were labeling like this, right? 5, 6, 7, 8. I'm starting someplace other than 1. Okay? You can use any method you want, and just to be clear, I'm not recommending that scale. You'll want to pick an appropriate one. But you can use any method to graph that you like. If you want to use slope-intercept method, go right ahead. If you want to use the intercepts method, you can do that. If you want to pick points that make each equation true to graph the line of that equation, that's your choice, okay? And then the solution is going to be the X and Y value that makes both of your linear equations true. So please make sure you're checking your solution back in your original equations to ensure that it is indeed correct. I've seen some solutions that are close, but if you were to put them into your equations, they would not make both sides of the equation true. So pay careful attention to that. For E and F, you're using your work, whether it's the graph or the solution you came up with, or just trying to put in different values into the equations you came up with, right? They're asking you under what conditions would it be better to have a party at one place versus the other. Well, you can do some modeling, put in some values for different numbers of pizzas and see what the costs are. Here your focus is for both of these questions on the cheapest option. Okay, so that would be page 1. Moving on to page 2, a couple of thoughts for you there. So on page 2, you're looking at a situation involving DVDs. Going through my notes over here as well. Okay. Again, you need to define your variables. Make sure that you are clear about the definition. Right? And then you're going to, in this same space, write the linear equations that make sense. Now be careful. I've seen some interesting things here. For example, if you have one equation that looks something like this, and you have a second equation that looks something like this, well, that just can't be, right? These are two equations about the same or related situation. They're working in tandem. They're a system. They're simultaneous, right? Therefore, 8x plus 10y can't equal 48,000 and also 500. That just doesn't make sense. So check your equations and make sure that they make sense, okay? You can refer back to the definition of your variables for help there. Number 3, you're looking at two different photo printers, okay? You've got Fast Photo and Pretty Pictures. At each of these places, there are different cost options. There are different fixed costs. There's a setup fee at Fast Photo of $10. There's a setup fee at Pretty Pictures of $6. And then there's different variable costs, costs that change based on how many prints you're making. Fast Photo, 69 cents per print. So depending on how many prints you buy, that will determine how much that part of the equation would cost you. right? Over here, pretty pictures, 99 cents a print, okay? As you're looking at this one, I recommend, they're asking you a number of questions. I recommend starting right off with writing and solving your equation first, so you know if there is a solution, and if so, what that solution would be. Okay, so define your variables, go ahead and solve those equations using any method you like so you have some understanding of this problem. Okay, now they ask you in A if there, the statement is there is no number of prints for which the cost at both stores is exactly the same. They want you to state whether that's true or false. The only thing I'd remind you here is you can't buy a fraction of a print. You can't buy, 13.87 prints, right? You have to have whole number prints. So think about that as you answer this question here. I think I've talked about fixed and variable costs. Okay, and then as you continue on, right, they're asking you, is it always more expensive? Which of these places might have been used by Jorge? So again, experiment with different values and see what you can conclude. All right, moving on to number 4. Okay, in this section here, they give you a variety of problems. There's actually 4 of them. They're asking you to choose a method and solve. That could be substitution, that could be elimination. If you want graph paper, you could be graphing. I would say be careful with your work here in this section. If you get a single solution, a single value of x and y that you believe make both equations true, please put those values into both equations and ensure that those values make the equations true, that the left side is equal to the right side. Okay? Just a reminder, if 2 equations have the same slope, the lines are parallel, and there will be no solution. When you are solving by substitution or elimination, that situation where you have 2 parallel lines will usually result in an outcome that makes no sense, okay? Something like this, like maybe 0 equals 6 when you do all your work. Well, obviously 0 does not equal 6. That makes no sense. It's inconsistent. The inconsistent case we discussed, okay? That happens when you have parallel lines, okay? And this would be where you have no solution. There's no point of intersection, okay? No place where there's an x and y value that would make both equations true because they do not overlap, all right? Also, we do have the case where 2 equations are different ways of writing the same line. Okay. When you have this situation, they may look different, but when you manipulate them, it turns out they're actually the same equation. You're going to end up with a result if you're using substitution or elimination that could be something like this. Okay, 0 equals 0. Well, yes, that's always true. Okay, that's always true. That's because this is the dependent case, okay, where there are infinite solutions. Because if you were to graph these, they're the same line. So the line is laying over itself. Okay, so just a reminder to be on the lookout for those situations there. Okay. All right, so after you deal with the top, they ask you some questions on the bottom. No solutions, infinite solutions. Well, that hints at the fact that there is at least one of the ones above that has no solution, which would be the parallel lines situation. And infinite solutions where they're actually the same lines. So use that to help guide you. And then in E, they ask you what method you chose to solve the very first one. There's no wrong answer here. We're just looking for you to identify the method you chose and then to explain why you chose it. Okay? And then finally, on the last page, you have a situation here with some cell phone plans. Okay? So cell phone plans, to be clear, right? If I'm looking at something like this, these are not the two equations that you have. Okay, they're a little different. Okay? Yes, they're using different variables, but you could imagine these equations just as easily being written like this. Okay? They're just being a little more creative. They're using M for the number of minutes and C for the cost, right? It's a cost function, so they're being creative and using C as the output, which is cost in this case. They could have just as easily said, let X equal the number of minutes and let Y equal the cost, right? The outcome. So don't be confused by that. They're just two different ways of talking about the same thing. You do have fixed and variable cost here. Remember, fixed costs are the ones that you can't avoid, like with the gym membership when we had to pay a starting fee, right, before we even touch a piece of equipment. That's a fixed cost, right? Setup fees, starting fees, things of that sort are your fixed costs. Variable costs are the ones that change based on your input, the number of months you attend a gym, the number of prints that you have printed at a photo printing place, that kind of thing. Okay. What else do I want to highlight here? Okay, so as you go into this particular activity, they ask you to, after you've talked about the fixed cost, to determine which plan you think is a better deal. This is personally you. Please use your rationale. Yours may be different from someone else's, but if it's well explained and I can follow it, both individuals may be right. Okay, it depends on how you might view the plans based on maybe how many minutes you tend to use. So something to think about there. Okay, as you continue on, C, when do the two monthly plans cost the same? Well, think about that, right? A solution that makes both equations true. Think about that. And then at the bottom, and again, for C, you can use any method you like, right? It's up to you. For D, they give you a table here, okay? You need to read the explanation here and complete the table carefully. If they tell you the first 40 minutes are free, right, then they are free. You can conclude that up to and including 40 minutes, there is no cost, $0, okay? So your table should reflect that, right? In E, they ask that you write an equation that models this situation. Now, you have input values here. Okay? Maybe you'll choose to call these, define these using the variable M, and maybe you'll define this using the variable C, or maybe you'll do X and Y. That's up to you. But you have input and output values. So whatever equation you write, check it. Make sure it works such that when you put in your input values, you get the output you expect. Okay? And then finally for F, is this plan better than either of the two original? Okay? You need to show some work, show some comparison. How are you thinking through that? And then be able to support your answer, right, accordingly. So that could be based on work, or that could be based on written explanation of your reasoning. And you may need extra paper, I have it, but I need to see something that clearly supports your conclusion, and of course I need to see clearly what your conclusion is. Okay? Hope that helps. Thanks.